So here's our last problem we're going to take a look at. Rather complicated looking truss. So we have a pin joint holding it in place here. However, we see there's no forces in the X, so the pin will not be exerting a force in the X to stabilize it. We have an expansion joint there in the end. All of these upper joints have loads on them. So 3, 5, 5, 6, 4, 4, 2 kilonewtons. All right, we see there's a lot of symmetry here. There's two along the bottom. It's 2 meters, 2 meters, 2, 2, 2, 2 going across. So that's easily dealt with. So if we look at from the base up to the top here, that's 4 meters. And so this is 2, 4, 6 up 4. So the slope here is 4/6. And then would be minus 4/6 over on this side. Okay. The problem says find the forces in members IJ, that's right here. EJ, here's E, see that down here, EJ. So we want this one, we want this one. And CD, well that's CD's here, so that's right across here. It's not asking for this one, but we'll just cut it here and let that happen. So we're going to cut a section out of this. We're going to cut all of these elements, these members, and we'll take out the members, and we're going to look at this side of the truss. We're going to throw away this side. Don't need all that complication. We're just going to look at this side. So we'll take out this member, put a force in relative to that pin. Take this out, put a force in relative to that pin. This one will go across, then we'll take this one out, put a force relative to that pin, but we'll talk about that in a second. And finally, relative to this pin, we'll put a force in here. Now, this is D, that's J. Let's look at FJD. We have these two in a line, this is coming down, and there is no load coming off of this joint. So this is the second rule of zero force members, so we have a ZFM. And that would be element JD right here. That's a zero force member. So when we do our section, we're cutting this, but we will not replace that with the force because it's not doing anything. All right, and so therefore the force that's in this piece will be the same. This is just in a line, so that's what the force is here. So we're just going to move that one over to here, and more or less, and everything will go fairly easy. Okay, so first thing I like to do, figure out the supports. We're going to work with this half, so we'll take some of the moments at A and solve for the force here at this expansion joint. So let's make that happen. Some of the moments at A must be 0. All right, so we have 2, 4, 6, 8, 10, 12 away for G. So GY, it's going up, it'll be going counterclockwise. We have GY times 12, so be that. Now, we're taking the moments at A. So going along the top here, this is lined up with A, so that does nothing. Now I have 5 times 2, negative, minus 5 times 2, 5 times 4, 6 times 6, minus 4 times 8 for this one, 4 times 10, and minus 2 times 12. There's all the parts. Set them equal to 0. Solve for G. Come up with GY is 13.5 kilonewtons. So we have that support. So what I'm going to do now is I'm going to go, now I know what the support is, I'm going to go look at this section where all of these members are going to be replaced by forces, and let's go there. And here we are. All right, so GY, we figured that out. That was right over here, 13.5 kilonewtons, so be it. And so here's FDJ, that'd be 0. So we can just look at that force continuing on through to E. Here's EJ, one of the things we wanted. I'm taking this to be tension relative to E. Fji, I have the force coming down relative to point I. So those are all the points I've set up. Now, next thing we need to do is start taking some moments. And the first logical one to me is, looks like J's a good spot. Why? J lines up here, so that wipes that out. EJ comes up through here. This is already 0, but it would have been zeroed out again if only because of that. So we've taken this one, and that one. That leaves us with one unknown. We'll be able to solve that. So that's a great choice. Summing the moments at J. And we set that equal to 0. All right. So we have, we'll start here at G. So G I have 13.5 kilonewtons, and that's 2, 4, 6 away. Let's just put these in there. All right, so relative to J, J's, the force at G is going up. That's counterclockwise, that's positive. So I have 13.5 times 6. So I've knocked that one off. All right, now I've got this one right here. If I go along the top line, that's 2 away, and it's going clockwise relative to J. So I have, let me just go down a line, minus 4 times 2. Over here, this is 4 away, same orientation, minus 4 times 4. This is 6 away, same orientation, minus 2 times 6. Okay. This is wiped out because it's aligned with J. This is wiped out because it's aligned with J. This is a zero force member, and it's aligned with J. Sort of double wiped out, we might even say. All right. And then the last thing we have is relative to J. The height here is 4 meters. So here's FCD. So relative to that, that's going around clockwise. So we have minus FCD times 4. So that leaves us setting that equal to 0. Solving for FCD, we get FCD is equal to 11.25 kilonewtons. And the result is positive, so we have tension. So we've solved that one. All right. Now, we need to do our next one. Where are we going to do that one? I'm going to suggest that we're going to look at E right here. Okay? So why would I do that? Okay, this is 0 to begin with. This is lined up with E as it comes across. EJ is lined up with E by name. All right. So, and look, if we go at E, this 4 kilonewtons comes in and hits that, so that's wiped out. So I'm left with this one, that, and then the GY. It wipes out a whole bunch of stuff. So, summing the moments at E. Okay, we'll ignore all the things that are inherently wiped out, but so let's just start with the things we know. I have this 13.5 kilonewtons, it's 4 away relative to E going counterclockwise. So I have 13.5 times 4, it's positive. This one gets wiped out, lines up here. So this one comes down, that would go clockwise, that's negative, minus 4 times 2. And then I have minus 2 times 4. All right, and now I'm left with, if I look at this piece right here, okay, this will have a horizontal component, and that component will exert a moment, and they'll have a vertical component coming down, but that'll line up with E, so that gets wiped out too. So what I need here to do this one is I need to get the x component times that distance. So we can start getting the x component, noting that the slope here is 4 by 6, and that's not a nice number. So let's see, it's 6 squared is 36 plus 16 squared is 16, so that adds up to 52. So this hypotenuse here is the square root of 52. All right, a little bit of a bizarre number. All right, so I need the x portion here. So let's see, if this is coming across this way, relative to E, that'll go clockwise, so it's negative, so we'll put that in, minus FJI times 6 on the root of 52. All right, that's the X part of the force. Now I have to multiply by a distance, this distance. All right, and we need to think about what that is for just a moment. So this is something that tends to bother students a little bit. How do you get this distance D in here? Well, here's the way I would look at it, basically off of similar triangles. So if we look at this triangle out here, all right, this is 4 by 6, 4 meters high, then 2, 4, 6. So let's look at, so 4 over 6, 4 to 6, and this is D to 4. All right, so let's look at that. The ratios here, this is 4 feet versus 6, so this is 4, that's D. So D is to 4 as 4 is to 6. That just comes out of similar triangles. Well, so if we just multiply the 4 here, we wind up with D equals 16 over 6. So we'll take that out, put in 16 over 6 in there. We now have one equation, one unknown. We solve for FJI. And we come up with 17.1 kilonewtons. It's positive for what we set up. So it is in compression, as we said. All right. So let's see what we got here. We figured out FCD. We figured out FJI. I need to figure out FEJ. That's the last piece to finishing this problem off. All right, and so this can be done a number of ways, quite frankly. We could be summing forces. That would work. We could sum forces in the X, would be a logical thing to do, because you got a lot of stuff in the Y, so this is going in the positive X, that's going negative X, that's going negative X. So that would solve for it. Would be nothing wrong with that. Alternatives, we could take a moment, and we could, by the way, we could do it in the Y. We have, because we just have one unknown, so some forces in the X, some forces in the Y. We could also take a moment. Just to be different, that's what I'll do. So I'm going to sum the moments at G of all places. Why did I choose that? Well, FCD lines up with G. EJ has an X component that would line up with G. FJI goes down this line, lines up with G. The 2 kilonewtons lines up with G. So it gets rid of a lot of stuff. That's always the reason you pick a moment, to get rid of crap. All right. If I look at FEJ, we know that this is 4, this is 2, and that's 4, so we know all that. So that's 2, 4, and the square root of 20 triangle. All right. So let's start setting all this up. So I'm going to take the moments at G. That does nothing. This does nothing. Here, this is 4, and that's 4 away. That looks really counterclockwise to me. So 4 times 4. This is 4 times 2. The 2 kilonewtons does nothing because it's at G. The 13.5 does nothing because it's at G. So we've wiped out the whole top. This does nothing because it's aligned with G. So all we're left with is EJ. The X component here does nothing because it's aligned with G. So now we have the Y component. So we're going to have, let's see, FEJ, if the vertical component is going like that. So that's clockwise, so negative FEJ. All right, we need the Y component, so that would be 4 over the root of 20. That's our trig. And it's 4 meters away. Multiply by 4. Set that equal to 0. And bam, we can solve for FEJ. And that would give us 6.71 kilonewtons. It's positive, so our assumption of tension is correct. And we are all done with trusses. Next time, we're going to begin doing frames and machines. Take care now.